Hello and welcome to this screencast on conversion between decimal and binary numbers. So just to recap, if I have a number, I'm going to choose 730. Okay, usually when we write down numbers we're using base 10. Okay, so we don't normally write the base down, but because I'm going to be converting between numbers of different bases, I'm going to do so here. Okay, so I have a decimal number, so this is base 10. I want to convert this to a binary number. Okay, so that's base 10. And I want to convert it to a binary number, which is base 2. Okay, so one of the methods we can do that is we divide our decimal number by 2 and find how much is left over. Okay, so 730 divided by 2 is equal to 365. Okay. With 0 left over. The reason why there's 0 left over is this is an even number, so it divides exactly by 2. Okay, so that's the first step of the algorithm. So we divide by 2, and what we do is we take the answer, the whole number part, which is 365, and then we divide that by 2. Okay, so 365 divided by 2 is 182. Well, it's actually 182 and a half, but I'm just interested in the whole number part. Okay, so 182 and a half. So 365 divided by 2 is 182, but remainder 1. Okay, because there's 1 left over. 2 doesn't go into 365, a whole number part. There is 1 left over. Okay, so we take our answer, 182, and divide that by 2 again. Okay, 182 divided by 2 is 91. And this 182 is an even number, so we've got a remainder 0. Okay, take the answer again, 91, divide that by 2, and we got 45, remainder 1. And we keep going, dividing by 2, or dividing the answer by 2, and finding the remainder. So 45 divided by 2 is 21, remainder 1. Sorry, 22, remainder 1. 22 divided by 2 is 11, remainder 0. 11 divided by 2 is 5, remainder 1. 5 divided by 2 is 2, remainder 1, and 2 divided by 2 is 1, remainder 0, and 1 divided by 2, well 2 doesn't go into 1 anyway, because 2 is greater than 1, it can't possibly go into 1, so it's 0 with 1 left over. Okay, so when we get to the end, we get to a stage where we have a number less than 2, we can't go any further. What we do now is we look at the remainders and we read them from bottom to top. Okay, top remainder is the least significant digit, and the bottom remainder is the most significant digit. So if I was to read off the remainders, I have my binary number. Okay, so 730 in decimal is equal, I'm reading from bottom to top, 1011011010 in binary, and I use a subscript 2 just to denote that's binary. So that's conversion from decimal number 730 to a binary number. Okay, another couple of things I'm going to show you now is it's quite common in computer science to use octal and hexadecimal numbers. Okay, now an octal number is base 8. Oh, excuse my writing. Now 8 is equal to 2 cubed. Okay, what this means is for every 3 digits in a binary number, that number is represented by only 1 digit in an octal number. Okay, 8 to the power 1 is equal to 2 to the power 3. So what I can do here is if I write down my binary version, or binary form of 730, I can group in 3s. So starting from the least significant digit on the right, I group in 3s. Okay, so I've got a group of 3 there, another group of 3, and another group of 3, and I just got a group, 1 on its own there. What I do now is I convert each group of 3 into an octal number. So 1 in binary is just 1 in octal, 0, 1, 1 in binary is 3 in octal, 0, 1, 1 in binary is also 3, and 0, 1, 0 is 2 in octal. Okay, so this means 730 in decimal is equal to 1332 in octal. Okay, and the other number system which is often used in computer science is hexadecimal. Okay, spelled it slightly wrong there, but it doesn't matter. Hexadecimal is base 16. Okay, so this means 16 is equal to 2 to the power 4. So for every 4 digits in a binary number, that's replaced by 1 digit in a hexadecimal number. Okay, so if we have a look at our 730 in binary, just write it out again. Okay, this time I group in 4s, starting from the least significant digit. Okay, so there's one group of 4, there's two groups of 4, and finally I just got a group of 2. Okay, so I convert this number, or each of these groups now, I convert into hexadecimal. So 1 0 in binary is 2 in hexadecimal. 1 1 0 1. Well, here I have a 1. I have 0 2s, I have 1 4s, and I have 1 8s. So this is actually 13. Okay, but instead of 13, we don't represent 13 hexadecimal. We actually use, better just delete it. We actually use D. Okay, just remember, 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. Okay, so instead of 13, I've written that down as D, and here I've got 10, and obviously we don't write 10 in hexadecimal, we actually write A. Okay, so I've got the number 2DA, and that's in hexadecimal. Okay, so now you can convert from binary to octal to hexadecimal numbers.